Okay, from this figure, we see that small company stock is much more profitable than large company stock or long-term government bonds. Yeah, but the price you have to pay is what? The volatility. Yeah, biến động. Large small company stock, you see the green line is volatile a lot. Yeah, in comparison to the long-term government bond, the blue line, you see the blue line is quite smooth, right? So we would like to know, we would like to measure, so how much volatility of small stock compared to large stock, compared to long-term government bonds. And I will tell you how to do this. Okay, in the previous example, we already measured the average return, right? For example, this is the average return bar of small company stock. Yeah, and this one is the average return of RB of the long-term government bond. And please notice that the two figures A and B, they have different scale. Yeah, here the vertical axis come to 200. So each interval here corresponds to 50%. And this in figure B, the vertical axis, yeah, on the vertical axis you see the different scale, yeah. One interval here corresponds to about 10%, yeah. So bear that in mind. Okay, now we know that small company stock, how do we know it's more volatile than long-term government bonds? Yeah, more volatile, what does that mean? This is the average return. Some year, the return of that year can be here, or even can be there. Okay, so it fluctuates. Yeah, it fluctuates, and the average return is over here. So what I'm going to do is I want to measure how much it deviates from the average value here. How much it deviates, the return. Yeah, and then I will say if the return of the stock deviates a lot from this average value, then that stock is more volatile than the other stock. Okay? So what we're going to do, we measure the distance between the return of each year here from the average return. In other words, I measure this distance. I measure this distance. Yeah, this distance. Blah, blah, blah. The distance from one return to the average value. Yeah, so basically this is what I measure. Okay, of the stock and of year T, yeah, and subtract for the average return of that stock, yeah, and then I take the sum, from yeah, this is the period of the figure. And here I do the same. For the long-term government bond, I take, this is the return for bond of year T, subtract for the average return of long-term government bond, and I take all the sum. And figure from 1926 to 2013. Okay, but wait, when I take the total of the distance, yeah, for year T, for any year, yeah, there's one problem that there's some year the return is negative. So it means this number become negative, and if we take the sum, yeah, it can, it can counterfeit, right? So what I'm going to do is to, to eliminate the impact of the negative side, because I want to measure the distance, only the distance, yeah? So I take the square, yeah? Okay, and I do the same here, yeah. Okay, and please tell me which number is larger, figure A or figure B? Yeah, figure A. The number in this figure A for sure is much larger this number in figure B. Because why? Because, yeah, look at the stock, the small company stock. This is only 150, the high point. And the high point is corresponding to 40, right? If you come here, 40. Yeah, this is minus about, okay, this one about 17%, minus 17%. Yeah, remember the different scale. Yeah, but when we measure like this, the number become very large. So I want to make it smaller by taking the average. Yeah, so I divided this number by n. I do the same for here. Yeah, divided this number for n. Yeah, so by doing so, I measure the distance, the average distance, yeah, of the return of the one financial assets from its average, yeah, from the value, the average value. And the higher distance, the larger deviation from the average value, I say that asset is riskier. Yeah, like the larger the deviation, the riskier of that financial asset is. Okay? Yeah. And this formula, yeah, is very popular in statistics. We call this formula variance. Okay? Phương Sai. Yeah? Phương Sai. Okay. And remember, okay, we move to this slide. This is the formula variance. But please notice that in this variance, we divided 40 minus 1. Okay? In my example, I use n. Yeah, I use n. Yeah, but I don't divide it for, I don't subtract for 1. So you can adjust here is n. There. It doesn't change anything, huh? Sorry. Here, we can use D. Yeah, D here. The number of the period or the number of years. Yeah. And notice one thing that here in our formula, we subtract for 1. Yeah, subtract for 1. This is a statistical technique. Yeah. Okay. For sample. Okay. And for population, we don't subtract for 1. Okay, there's explanation for this, but please take a look at statistics course. And then this is the variance, and remember this one is still had a square. Yeah, so now we take the square root of the variance. Yeah, take the square root of the variance. We have standard deviation, đều là chuẩn các bạn ha. And this one stands for sigma, huh? This one is sigma square. This one is sigma. Okay. Okay, that's how we measure the risk, yeah, of a financial asset in finance. And of course, there are also measures of risk, also another measures of risk. But this measure is the most basic one in finance, that we measure the risk using the variance and, okay, come up with standard deviation. Variance is the intermediate step. Okay, finally, we had to report the standard deviation. Okay. Okay, please take a look at this example. Yeah. Okay, we had year. We measure variance and standard deviation for, in this example, we have 4 years, and this is the actual return. And okay, this one is given. and the rest we had to calculate ourselves. Yeah, so this is the actual return. In order to calculate the variance, yeah, we need what? We need R of each year, RT, and we need the R bar or the average. Yeah, the average return. So we need to take the average return. So we take the total here, yeah, 0.44, yeah, and we divide it by 4, and we get this. Yeah, we get this. And then we measure the deviation from the mean. This one is equal to 0.15 subtract for 0.105. Remember there's 0 here, but it was drop. Yeah, for symbol. And here this one equal to 0.09. Subtract for the average value is 0.105. Blah blah blah. And we take the sum. And sum here you don't see the number, just 0.00. But actually there are more digits later. Yeah? Okay. And now we have, what do we have? Yeah? Deviation from the mean. But here, this number, yeah, is not square. Yeah, it's the level number. So this one we take is equal to 0.5 square. Yeah, and then the total is 0.0045. Okay, this is the total correspond to this t minus 4r bar. Yeah, square. Yeah, and now we had to divide it for t minus 1 in order to get variance, right? This is what we do. We divide it for, this one is t, yeah, minus 1. This is the variance. And we take the square root of the variance, and we take the standard deviation. This is the square root of this number. Yeah, okay. And again, this variance and standard deviation is measured based on the historical value or is under measure. And now we're going to expose measure, yeah, by using okay, we call expected variance and expected standard deviation. Okay, again, we have the probability of some scenario. We multiply for the difference, the deviation between the possible return and the expected return. Okay? And after we calculate the variance, we measure the standard deviation. Okay, go back to this example. Yeah, we already measured the return of stock C and the expected return of stock D. And now we're going to measure the return. And now we're going to measure, we already calculate the expected return of stock C and stock D. Now we calculate the expected variance and standard deviation of stock C and stock D. Yeah. So what I'm going to do is I take, okay, variance of RC equal to, okay, 0.3, yeah, and this is 15%, separate for 9.9, yeah, and we take the square, look at the, this one again, yeah, okay, yeah, and plus 0.5, yeah, this is 0.2, huh? Yeah, this is the variance. And after that, we take the standard deviation, we measure the standard deviation of stock C by taking the square root of the variance of us of stock C. Yes. Okay. And please do simply to stock C. Okay. Okay, we have one real life example. Please take a look at the Excel file that I sent to you. In this Excel file, I'm going to explain. Okay, we have three stocks. Yeah, one is the VNX and the GMADEX and the MPB, that is the military bank. And time here corresponds to a month. So I just make it generally from time 1 to 10. Yeah. And the VN index here I consider like a stock. It's as long as the price of that stock has changed over time. Yeah. Because the index has changed over time, look like the price of the stock. So I consider it, like a stock. Yeah. So basically, we have three assets, and for each asset, please measure the mean of return or the average return, and please measure the variance for the return of each stock. Yeah. And please do it at home. Yeah. And now we go to the second part of this chapter. Okay. Now we know how to measure the expected return and the value of the risk of a single asset. And now we put it into a portfolio danh mục. So basically, a portfolio is the combination of security and at least two security. Yeah, and with the portfolio weights that's the one. Yeah, so we call W stand for weight. Yeah, and this is the weight of stock. That is N is the number of security I, stock I, and P is the value of the price of security I. Yeah, and we take this as the numerator and the um, denominator. Uh, yeah, we have this is the total value of our portfolio. So this measures the portion of the of stock I in the portfolio. Yeah, and remember the total, the sum of weight is equal to one, sum to one. So here you can say, okay, can weight, the weight can be negative. Can a weight can be negative? Tỷ trọng có nhỏ hơn không được? Tỷ trọng của một cổ phiếu nào đó, WI. Yeah, and the answer is yes. Yeah, okay. In your portfolio, you have when you invest in stock, you have long position. That is, yeah, you buy the stock, and the short position, yeah, you sell the stock. Yeah, in Vietnam we don't have a short position, gọi là bán không các bạn, short sell bán không. Yeah, but in developed financial market we have short sell. I mean we sell what we don't have. Bán không, bán cái gì mà chúng ta không có. Thì làm sao bán được các bạn? We borrow. Yeah, if I don't have a stock, for example, if I don't have Vinamilk in my portfolio, I can borrow Vinamilk from other people and sell Vinamilk. Yeah, bán không đi nào các bạn. We paid, we traded at the price, yeah, we go down. So we can sell the stock today and wait until the price went down to at the level we want, and then we buy back the stock and we go back, we return it to the one that we borrowed. Okay? Okay, so WI can be negative. Okay, this is example to calculate the portfolio weight. Very simple, and we already have the results, so please do it yourself and check. Okay, now for a single stock, we know how to measure the return and risk. But when we put the single stock, two single stock in one portfolio, how to measure the return of that portfolio, the risk of that portfolio. Okay, that's it. the main job we're going to do in this session. Okay, look at this. The expected return of a portfolio. Suppose that our portfolio only have just stock I and stock J. Yeah, stock I and stock J. Stock I have expected return, huh? R and expected return J. And stock I also have the variance I. Yeah, you say variance of stock J. And the weight, yeah, the portion of stock I in our portfolio and the portion of stock J in our portfolio. Okay, this is the expected return of the portfolio that equal to the weight of stock I multiplied for the expected return of stock I and plus the weight of stock J multiplied for the expected return of stock J. Makes sense, right? Yeah. And are we going to do the same with variance? Look at variance. The variance of the return of portfolio và portfolio. Yeah, a portfolio. Okay, look at this. Yeah, the square of weight of stock I multiplied for the variance of stock I and plus we do the same for stock J and plus 2. Yeah, multiply for weight of I, weight of J, and covariance IJ. Here we have the new factor, covariance, hệ phương sai. Đây các bạn, covariance. Okay, okay. And when we have the variance, we take the square root to have the standard deviation. And now let's talk about the covariance of security I and J. What is covariance? Hệ phương sai, like name. That is the co means together. Yeah, variance. So that is the volatility, the move, the co-move of two stocks. It measures how much two stocks move together. It measures how much two stocks move together. Yeah, you see, a positive covariance can be negative or positive. If it's positive, it means that both variables tend to be high or low at the same time. What that means? It means they move, yeah, in the same direction. If stock A increase, stock I increase, stock J also increase, and vice versa. Stock I decrease, stock J also decrease. Yeah, and of course we do it for a long time. So what that means what I told you when they move together in the same direction, it's a loose ways of speaking. They're not always like that, but generally over the period we measure, they move the same direction. The positive covariance, they move together, yeah, but the negative covariance, they move in the opposite direction. Stock J, in general, stock I move up, stock J move down, and vice versa. Yeah, so this is how we measure covariance. Look at the formula. Yeah, this is the return of stock I at time t, yeah, in any year t, any period t. Subtract for the expected return of stock I, or that is, this is expected return is the average return, the average return. So this one, this factor is the deviation of the return of stock I in any year from its average. Yeah, and we multiply for the same, we do the same for stock J. Yeah, the deviation of the return of stock J from its average value. Yeah, and then we do it for each year, and then we sum it and we divide it for 40. 40. This is the number of the period. Yeah. And this one we do it for population, tổng thể các bạn. But we don't have population. We have only sample. So we divide it for t minus for 1. And the covariance of a variable itself, we replace the I here with the J here with the I. That is the covariance of stock I with stock I. And if you calculate this one, yeah, that is the square, right? And this is exactly the variance of stock I, or in other words, the covariance of a variable with itself is its variance. Okay?